Good morning everyone. My name is Ishita Chaturvedi and today I am going to present my project on 3D transformation and 3D translation. This topic is an important part of computer graphics because it helps us understand how objects are moved, resized, and manipulated in a three-dimensional environment. In this presentation, I will first introduce the concept of 3D graphics. Then I will explain the 3D coordinate system and different types of transformations. After that, I will focus on 3D translation, discuss translation matrices, solve a numerical example, and finally cover applications, advantages, limitations, and a summary of the topic. The main goal of this presentation is to understand the mathematical foundations and practical applications of 3D transformations with special focus on 3D translation. We will also see numerical examples and visualizations to better understand how objects move in three-dimensional space. After this presentation, we should be able to understand the basic concepts of 3D computer graphics, explain the mathematics behind 3D translation, apply transformation matrices to coordinates, and visualize object movement within a Cartesian coordinate system. This slide shows the complete outline of the presentation. We will begin with the basics of 3D graphics and coordinate systems, then discuss various transformations. The main focus will be on translation, including its matrix representation and numerical example. Finally, we will explore applications, advantages, limitations, and conclude with references. 3D computer graphics use three-dimensional representations of objects that are stored and processed by computers. These graphics allow us to create realistic models and environments. The three key concepts are modeling, which involves creating shapes, transformation, which changes an object's position or appearance, and rendering, which converts the 3D model into a visible image. In a 3D coordinate system, we use three axes: the x-axis, y-axis, and z-axis. The x-axis represents horizontal movement, the y-axis represents vertical movement, and the z-axis represents depth. Any point in 3D space can be represented using three coordinates written as x, y, and z. A 3D transformation is the process of changing an object's position, size, or orientation. The major types of transformations are translation, scaling, rotation, reflection, and shearing. These transformations are widely used in computer graphics, animation, gaming, and simulation applications. Translation is one of the simplest and most important transformations. It involves moving an object from one location to another without changing its size, shape, or orientation. To perform translation, we add specific translation values to the original coordinates of the object. The new coordinates of a translated point are calculated using simple equations. We add the translation values tx, ty, and tz to the original x, y, and z coordinates. This gives us the new position of the object in three-dimensional space. To perform translation efficiently in computer graphics, we use homogeneous coordinates and represent translation using a 4x4 matrix. Matrix representation makes it easier to combine translation with other transformations such as scaling and rotation. Let's understand translation with an example. Suppose we have a point P with coordinates 2, 3, and 4. We apply a translation vector of 3, 2, and 1. By adding these values to the original coordinates, we obtain the new point as 5, 5, and 5. This demonstrates how translation changes the position of a point. This diagram visually represents the translation process. The object starts at its original position and moves to a new position based on the translation vector. The shape and size remain unchanged, only the location changes. 3D translation has many real-world applications. In computer games, it is used for character movement. In CAD and CAM software, it helps position and assemble parts. It is also used in movie animation, virtual reality navigation, and medical imaging for constructing and analyzing three-dimensional models. There are several advantages of 3D translation. It enables smooth and realistic movement of objects, supports efficient matrix-based calculations, provides better depth control, and offers a standardized mathematical approach that is used across almost all modern 3D software. To summarize, 3D transformations form the foundation of modern computer graphics. Translation is used to move objects by adding offsets to their coordinates. Through homogeneous matrices, translation can be combined with scaling and rotation to create complex animations and realistic visual effects. Thank you everyone for listening to my presentation. I hope this session helped you understand the concepts of 3D transformation and 3D translation. Have a great day.